Good morning. My name is Isha Murray, and today I'm here to present on the topic interprocess communication. So let's start. So these are the contents which we are going to discuss in this PPT. So that's what IPC is. Here's the diagram for interprocess communication, how one process or more than two processes communicate with each other through IPC mechanism. So, what is the importance of IPC? Why IPC is necessary? So, as IPC allows inter-process communication, so it also allows different programs to run in parallel, share their data, and to communicate with each other. IPC techniques also speeds up the execution of tasks. IPC also ensures that the tasks running are running in particular or fixed order and also makes sure that the task is running correctly or not. IPC is also important for the efficient operation of an operating system. Also, when we think of how the data is exchanged with the tools and components like keyboard, mouse, graphical user interface, and system, it is all done with the use of IPC. Operating system uses IPC to exchange this data with the tools and components which the user uses to interact. Multiple programs in the PC which will run at the same time is also done with the help of IPC. So these were some necessities of IPC. Now there are two kinds of processes in inter-process communication that are independent processes and cooperating processes. So, independent process. It is the one which does not require to communicate or coordinate with other process to perform its own task. This is the one which is independent of others. It does not require any other process to communicate so that its own task is performed. ये किसी पे डिपेंड नहीं करती है. खुद का काम है तो ये खुद कर लेगी. किसी और प्रोसेस से इसको कोऑर्डिनेट करने की कोई नेसेसिटी कंडीशन नहीं होती है. एंड ऑल्सो ये किसी और अदर प्रोसेस के टास्क परफॉर्मेंस पे या उसके एग्जीक्यूशन पे डिपेंड नहीं करती है. इट्स completely independent. That's what its name is, independent process. Here comes the cooperating processes. Cooperating processes are quite different from that of independent process. Cooperating process require or need to communicate and coordinate with other process to complete their task or to perform their task. Unlike independent process, they there is a condition that they depend on other process so that they can work together and achieve a common goal or share their resources. They may also need to synchronize their execution, exchange of data or messages, or coordinate access to shared resources. As they share data and they work together to perform a task or to achieve a goal, so there is a need of synchronization in these cooperating processes. There are several reasons for allowing the processes to communicate or to cooperate with each other, and these reasons are as follows. First reason is information sharing. As we all need to share data in our daily life, we share so much of data. Similarly, the processes or the programs also need to share the data and information to perform complex tasks or to exchange the data. And the cooperation between these processes allow them to share the data and to synchronize their activities, to share their resources. Here is an example. Suppose a client in a server architecture, a process cooperate to exchange requests and responses, also enabling data sharing and providing services. Here, in all conditions, there is a need to share the data and information. So, information sharing is one of the main reasons for allowing process to communicate with each other to cooperate. The second reason is computational speed up. As we already discussed, that IPC helps in speeding up the process or to speed up the performance of tasks. So this is done by IPC as it allows or it divides a task into smaller subtasks, and then these smaller subtasks are executed concurrently, and in this way the overall speed of the process is increased. The task is executed more fast, and as the portion of task is divided into number of processes, the overall execution time is reduced as the workload is reduced on a particular process. And this parallel execution can significantly improve the system's computational speed up and throughput, and enabling the faster and more efficient processing. Modularity and convenience are also the reasons for allowing process cooperation. Modularity means the breaking down of a complex system into smaller and interconnected processes so that each process can focus on a specific functionality or module, and thus making the system more easy to understand and to develop, also to maintain. It becomes easier as one module or one process performs a specific task, so it becomes easy to understand and develop. Also, modularity allows the code reusability and scalability and independent development of different components as the processes are distributed. So it becomes easy to develop these independent processes, also to reuse the code, and enhancing the flexibility and reducing complexity in software systems. So modularity is also important. And convenience means to allow the process to work together simultaneously or seamlessly. Basically, it is important for the process to communicate and to coordinate and to synchronize their actions so as to work together. So this is done by the convenience, as convenience simplifies the development and management of complex systems, and also it enables the integration of diverse, which we have made different processes. It helps to integrate the diverse software and hardware component. So convenience is an important reason for allowing process cooperation. So here are the two techniques or methods by which process cooperate with each other. These are shared memory model and message passing model. So what is shared memory model? Let's understand. Basically, shared memory model is a mechanism for interprocess communication which allows two or more processes to communicate with each other by sharing a common memory space for exchanging the data. If we understand it more easily or simply, ये common memory space provide करती है जो कि दोनों प्रोसेसेस शेयर करती है, और इस मेमोरी स्पेस के थ्रू दोनों प्रोसेस एक दूसरे से कम्युनिकेट करती है और डेटा एक्सचेंज करती है, and it is one of the fastest IPC mechanism available for interprocess communication. And the created memory space which the processes share with each other is created by a single process. मतलब if a single process has created a memory space, then more than two or many processes can share this space for sharing the data and to communicate. And this portion of memory is basically a physical memory, and which is allocated or managed by the operating system. And once this shared memory region is created, multiple processes can access the memory space and modify the contents of the region as they share data. So they can modify the contents and share its own data with the process which who has created the memory space, and also with the other processes which are sharing the same memory space. Here is a diagram for understanding the shared memory model in a better way. So here there are two processes which you can see, process A and process B, and this blue region which is shared, this region is the common memory space or region which the process A and B are sharing in common, and whatever data they need to share, uh, is kept in this region, and the process A and B can share or exchange their data with the help of this common memory space. And in this way, the shared memory model allows the inter-process communication and to process to exchange the data by allowing them to provide a shared memory space. These are some advantages of shared memory model. Firstly, the speed of the overall mechanism or overall program is increased as there is directly sharing between the processes, and it is one of the fastest technique to share data. Also, the efficiency of the program is increased as there is direct sharing of memory space and no complex data structures are required. The flexibility also increases as any kind of data, including complex data structures like arrays and linked lists, can be shared. So flexibility is also increased. There are also some drawbacks of the shared memory model, which are synchronization and security. Synchronization means as the task is divided into smaller subtasks, so they need to synchronize with each other to perform a particular overall complete task. So that must be taken care of, that the synchronization is done properly. So the shared memory model, there is no race condition which arises and the conflicts doesn't arise. Also, as multiple tasks have access to the same memory, there is a risk of data corruption or unauthorized access. So the security need to be tight, and which is a drawback of this model. The second technique for interprocess communication is, or the for cooperation, is message passing model. Uh, in message passing model, there is no common memory space shared between processes. Here, the processes send and receive messages and share the data. Here, one process can send message to the other, which may contain any data structure or any instructions. Message passing model can be used in both synchronous and asynchronous modes. In synchronous mode, the process need to wait for the process to receive the message, while in asynchronous message passing, the sending process does not wait for a response from the receiving process. It can continue executing immediately after sending the message. इसको वेट नहीं करना पड़ता है एक मैसेज पहुंचाने के बाद कि दूसरा प्रोसेस का रिसीव होने का, ये वेट नहीं करती है, एक के बाद एक डायरेक्टली प्रोसेस एग्जीक्यूट कर देती है, सेंड कर देती है मैसेज टू अदर प्रोसेस को. Here is a diagram for better understanding of message passing model. Here simply the process A and process B send message to each other through the help of kernel for sharing of data and information. These are some advantages of message passing model. One advantage is that it is relatively simple as compared to shared memory and flexible also, as very easily process communicate with each other by sending and receiving the messages. Also, one advantage is that there can be any kind of data or instruction shared between the processes while sending message and receiving message. Also, there is the process are synchronized here, since one process can block other until the message is received by the receiving process. जब तक receiving process receive नहीं कर सकती, sending process block कर सकती है. So here is a better synchronized. There are also some drawbacks of message passing model, which are, it is not as fast as shared memory model. It is quite slower than this, since the message must be copied or transferred between processes. Takes time. Another is that it is complex to manage the message queues, because every time message queue has to be created when the processes participate in message passing. So it's quite complex to manage this all. Now we'll discuss the methods used in computer networking for the transmission of data over a network. that are unicast and multicast. Unicast is a communication method in which there is a one sender and one receiver. Means the data is sent and received from one source to another, and only the intended recipient receives and processes the data. It is like one-to-one communication model where the sender addresses the data to a particular recipient using its unique address. Multicast is another method of data transmission. It is a communication method in which there is a single sender, a single message is sent from one sender, and there are multiple recipients to receive the data simultaneously. In this mode, a single packet is transmitted from the source and it is copied and delivered to multiple destination. मतलब एक सेंडर होता है और उसी सेम टाइम पे मल्टीपल रिसीवर्स होते हैं उस डेटा को रिसीव करने के लिए. सो दिस इज मल्टीकास्ट. Here is a diagram to understand the difference between unicast and multicast. So, let's see in this unicast diagram, there is only one sender and only one receiver is receiving the message sent from the center. While in multicast, there is a single sender and there are multiple recipients to receive the same message from the same sender. So this was the difference between unicast and multicast. So here is a summary of what we studied in this presentation. What is IPC? What are its advantages? What is its necessity? What are the techniques involved? What are the techniques of data transmission? And this was what we studied in this PPT. So that's all about IPC. Thank you.